The Optima Ultimate Streetcar Challenge attracts a wide variety of different cars. However, the Nissan Frontier, or Navara D40 as we refer to them back home, seems to be maybe the least likely platform that you'd choose if you want to go road racing. We're here to find out a little bit more about why this vehicle was chosen and what's been done to it. So yeah, let's get to that first question. Why on earth would you choose a Nissan Frontier pickup truck for a road race application?
So that's the number one question I get at every event I go to. And the short answer is I own LOJ conversions and I make LS swap kits for Nissans and Infinitis. And when I chose the Nissan Frontier, I wanted to build some Nissan platform that was wild and different that hadn't been done before. And when I originally put this truck together, that's what I built it for, was to just sit in my booth when I went to shows and attract people to the booth for seeing something different. And then I got into racing it. Actually, at the Ultimate Streetcar Invitational last year was the first time I ever had it on track, and it turns out it actually works. So it's kind of gotten the name now of Accidentally Awesome because it works.
Now, to be clear, there is also a truck category for the Ultimate Streetcar Challenge. So you're not out here on your own, are you?
No, I'm not. This is actually the highest truck participation we've had in any event. I believe there's 14 trucks invited to the Invitational this year. Most races range between 5 trucks to a dozen. And it's been pretty good. This is the second year that Optima has been running the truck class. Last year was the first year. So turnout's been good, support's been good, and we've been having a lot of fun.
In terms of engine options, there are a lot from Nissan that would make sense. The VK56 5.6 litre V8 is well tried and true. So why go the LS route?
Well, again, with my business, going the LS route helped promote my business. But at the same time, as great as the VK56 is, as well as the VK45s that we've had here as well, and a VK56 would actually be a bolt-in conversion in this truck. I don't think there's anybody anywhere in the automotive aftermarket that would argue that the LS is the lowest dollar per horsepower engine that you can buy. Yes, there's a lot of awesome higher tech engines out there, but if you want to go fast for the least amount of money invested, especially in the States, the LS has a ton of aftermarket support for making big power.
Yeah, I think that's really important when anyone's looking at a platform to build from. I mean, just purchasing something where there's so much aftermarket support is going to make your life so much easier. And when things are manufactured in mass, obviously the cost comes down. So cost to build this equivalent LS, obviously with the twin turbos, which we'll talk about, versus a comparable VK56, suffice to say, cheaper to do the LS?
Oh, by far, yeah. I think the total dollars invested in this engine, including buying the core motor, and it's an all aluminum block, 6 liter, is $5,000 or $6,000.
Now, we hear about all of the people going out and buying the junkyard truck engines normally with a cast iron block and bolting on some eBay turbos and making 1,000 horsepower and happy days. Now, you've gone a slightly different route. What are the parts that you have used to make this combination? Let's start with the internals. And what do you need to do internally with the LS to make it capable of supporting boost reliably?
Okay, so this is, as I said before, it's a 6 liter LS. It's a Gen 4, so it's a 58X reluctor on the crank. The crank and block are stock, right from the vehicle it came out of. It's got a rod and piston combo in it. They're Molle pistons and I believe Lunati rods. It's been a while since I put it together. But other than that, some King tri-metal coated bearings. Was very diligent in the assembly of the motor, making sure my bearing clearances were good, making sure everything was clean, got my ring gap set right for a boosted application. And other than that, the bottom end, I did some tricks with hand porting the oil galleys through the block because this is still a wet sump. So I wanted to make it the best wet sump I could make it. So I ported a lot of the galleys in the block to reduce restrictions of flow, ported the oil pump. It's an aftermarket oil pump, but stock volume, just high pressure. And the heads are factory Gen 4 rectangular port heads like you would find on an LS3, but they've been CNC ported. and it's got springs and retainers and an aftermarket cam in it, and that's really about it.
So nothing essentially too wild. I just want to focus on that oiling system a little bit.
Sure.
Often for a track application, we find that the factory wet sump is problematic. Essentially, the oil will slosh away from the pickup, and it doesn't take a lot of air to be picked up before you have bearing problems. Now, I did notice when I was wandering around this that you are running an AccuSump system as well. Is there anything on top of the AccuSump you're doing as the baffles for the sump or anything else?
So yes, I actually took the factory cast aluminum oil pan and I cut it apart and welded a kick out onto the side to increase the capacity. I put trapdoor baffling inside it. It's got an improved racing crank scraper on it to keep the oil in the sump as best as possible. And the total system capacity with the 3-quart AccuSump is actually 3 gallons or 12 quarts now. So there's a significant amount of oil in the system that it would have to blow through before picking up air.
All right, let's talk about the turbochargers. What have you got on there at the moment?
So they're BorgWarner Airworks S257 SXEs. That's a 57 millimeter compressor wheel. I believe it's a 60 millimeter turbine wheel and a 1.09 AR hot side. It's a journal bearing turbo, not water cooled, just oil cooled. It's kind of a good, I would say it's a budget bridge between the cheap eBay turbos and something like a Garrett G Series. There's a lot less money invested in these turbos. Unfortunately, they don't have the response of a ball bearing counterpart, but they fit the budget and they supply the air that I need to make the power.
And what sort of boost are you using in it, and what sort of power is that resulting in?
So this has only been on the dyno once, and it had 52 millimeter turbos on it at that point with 81 hot sides. And at that point, at 13 pounds of boost, it put 700 to the tire. Now, since then, when I upgraded to the 57 millimeter turbos, we noticed in the Haltech data logs that I picked up about 13% airflow at the same boost level. So if you do the math, you're consuming 13% more air, 13% more fuel. You should be making 13% more power. So 700 is now what, 770, 800 maybe? And that's at 13 pounds. Now we've tuned it all the way up to 20 pounds. Right now, when I'm out on the track, I have it set so it's 13 pounds when the boost comes in, and it ramps to 16 by redline by using electronic boost control. And that helps mitigate that turbo surge that you get can upset the chassis of a turbocharged vehicle on a road course. This truck is all-wheel drive, so that helps as well, but the combination of the two helps it stay very composed when I'm going around the track.
I can imagine without the benefit of the four-wheel drive, with most of the weight being on the front axle line, traction would have been an issue. Two-wheel drive, is it still an issue four-wheel drive, or is it hook up pretty well?
It'll do all-wheel burnouts if I want it to. There's actually one of the previous events of this year, one of the other participants had some dash cam of me doing a four-wheel power slide around a turn. So it can, but it's much easier to control. It's a 70-30 torque split, and it's fully mechanical, so it's 70% at the rear wheels. And the front differential is an open differential. So, it's not as it's got a little bit of a rear wheel drive behavior to it because it's got actually a Y62 Patrol rear diff in it with a factory Torsen LSD. So, it'll spin both back wheels and only one front. So it gets a little bit of oversteer behavior, but it's much more manageable with the all-wheel drive for sure.
What transmission and transfer are you using to get this to be all-wheel drive? Obviously, when you're starting to mix and match parts from GM and Nissan, everything gets a little bit messy. So, yeah, tell us what you've done there.
So the transmission is a TR6060 out of a US 5th gen Camaro ZL1. So that's the version of the transmission that has the tighter gear spread, and it has a built-in transmission oil cooler, which I have plumbed into this to help keep the trans cool. What I did at that point was I actually installed, the first iteration was a Corvette main shaft, and then I upgraded to a Dodge Viper main shaft, but instead of putting a normal TR6060 tail housing on the transmission, I put a tail housing from a C6 Corvette. And if you're familiar with the Corvettes, they're actually a transaxle, and the diff bolts directly to the trans. So what that did for me is gave me a flat flange to design my own adapter to then put a Trailblazer SS transfer case behind the manual transmission. So I'm running essentially a modified factory GM transmission with a modified factory GM transfer case. The differential drops on the same side as a Nissan, so the drive shaft is on the correct side with that transfer case. And then the differentials and axles are all factory Nissan, and the drive shafts are custom.
So almost like it was meant to be.
Pretty much, yeah. Like I said, accidentally awesome.
Let's talk about the engine management. What
Sure.
have you got in there, and what are you actually utilizing in terms of functionality from it?
So it's a Haltech Elite 2500. It's the standard Elite, not the T. I have the biggest thing to me is data. So I have intercooler coolant temp sensors because it's a water to air intercooler setup. Obviously, all your standard engine parameters that I'm monitoring. I did install one of Haltech's I/O boxes to be able to tie all the additional inputs and outputs in: oil temp, oil pressure, fuel pressure, boost pressure. Everything that you could possibly want to know about this motor is being logged in the Haltech, and I have engine safety parameters built in so that if anything goes wrong, if I do lose oil pressure or anything like that, it will put into engine protection mode and save me a costly mistake out on the track because I wasn't watching gauges close enough.
In terms of those engine protection strategies as well, I know the Haltech is capable of closed loop knock control. I'm wondering if you're using this, if knock is an issue given the fuel you're using, or something you just don't need to worry about.
We are logging and watching knock. My tuner and I have worked with this. The guys over at SSG Garage do a lot of the tuning on this for me, and we've never had an issue with knock, but I do run a mix of VP's X98, which is a 98% ethanol fuel, with pump 93 octane to essentially end up with E50, and that's really just because there's no E85 stations within driving distance of where I live, so I use the VP fuel.
So I'm assuming they're running around E50, you don't feel you need the extra octane and cooling effect of running E85, E98?
Not at the power level I'm at, and if I was going for a max effort, max power drag application, sure, but for me, it's all about keeping this alive and being conservative on the tune. I'm looking at exhaust manifold back pressure and looking at my pressure delta on the exhaust manifold to the intake manifold to make sure I don't go the wrong way on that. With the exception of when I have it turned all the way up to 20 pounds, at that point, from 6,500 RPM to 7,200, I'm inverse on my EMAP, but it's only for that small RPM range. And I rarely ring it out that far when I'm on the track anyway. It's more of a 6,000 RPM shift point. So, the truck does really well, and it survived a season of flogging on it. So.
In terms of the future, what modifications have you got in mind for it? What have you found that maybe weak points or need some additional attention, or is it perfect the way it is?
Well, the biggest thing, just like me, the truck needs a diet. It is very heavy. Truck with driver is just under 5,000 pounds. So it's 4,720 without me in it, with a full tank of fuel. And the other thing is, it's a hodgepodge of factory Nissan parts, but other than the Viking coilovers that are on this truck, it's on stock control arms with rubber bushings. The rear suspension is a full independent suspension setup from a US Armada, which is basically like your Patrol. But again, all of the arms are stock bushings, stock ball joints everywhere, the stock sway bars. So there's a lot of body motion and a lot of change in alignment as you're going around track because of all the compliance in those bushings. So the plan for this off season is to basically put spherical bearings, Heim joints, wherever I can to take that compliance out and just put it on a diet. If I can get 500 pounds out of the truck, that would do tremendous things out on the track for sure.
Yeah, I mean, every little bit counts, but 500 pounds is 10% of the weight essentially, so yeah. That's not even a little bit. Yeah. Look, it's been great to get some insight into the truck. Obviously still running the car here today at Las Vegas Motor Speedway. Wish you all the best and look forward to seeing where it comes out. Thanks
so much.
If you like that video, make sure you give it a thumbs up, and if you're not already a subscriber, make sure you're subscribed. We release a new video every week. And if you like free stuff, we've got a great deal for you. Click the link in the description to claim your free spot to our next live lesson.